Welcome to week 3 in statistics. This week we're going to play with scatter plots, correlation, linear models. The goals are listed here under week goals, and this week we're going to do 3 sections, the last 3 sections of chapter 2. To play with scatter plots, correlation, and linear regression, a couple things: you need tools and data. StatKey is a tool we'll use often. And in StatKey, we'll play with 2 quantitative variables to do regression. And they have a lot of data options here. Some of these are from the 3rd edition of the book that we're using. Some are from the 4th edition. Doesn't matter too much which ones we use. They're similar enough, although there's some things that are in the 4th edition and not in the 3rd. I'll show that in a moment. One cute example of correlation is cricket chirps versus temperature. Now, we should look up the data set to be clear what chirps and temperature mean. So let's see, textbook data set descriptions and textbook data sets. I have some also in Google Drive. Let's look at the descriptions. And I'm just going to search here for crickets. And here's the cricket chirps data set. So it's a small data set, only 7 observations, but we have the air temperature in degrees Fahrenheit, and we have cricket chirp rate in chirps per minute. Now, looking at the graph here, in math, outside of statistics, we usually call the horizontal axis the dependent axis, dependent variable. Vertical is independent. In statistics, we call the horizontal or dependent variable the explanatory variable, and the vertical, the independent variable, we call that the response variable. And so the way it's set up here is that temperature is a response to the cricket's chirping. So somehow the chirping changes the temperature. So that doesn't sound right. So I'm going to switch the variables here with the switch variables option. In this case, as the temperature increases, that increases the chirps per minute of the crickets. That seems more reasonable in terms of explanatory temperature and response, crickets chirping more often per minute. StatKey does a bunch of calculations here. Mostly what we care about are the correlation value, the slope, and the intercept. There are ways to incorporate some of these other values to do a hypothesis test on the correlation. We're not going to get to that in this course. You would do that in a second course. So as far as correlation goes, if it's close to 1 or -1, we'll call it a strong correlation. And if it's closer to 0, we'll say it's a weak correlation. And if it's a weak correlation, we're really not interested in exploring the related linear model. What's the linear model? Linear line, y equals mx plus b. M is your slope, b is your y-intercept. So we're going to be exploring calculating correlation based on 2 quantitative variables that we think are related, and then if there's a reasonable correlation, then we'll calculate the slope and the y-intercept to get a linear model that we can use to make predictions. Let's check out another data set. College experience, feel good versus phone unlocked. So I should look up what phone unlocked means and what feel good means. And when I go to search my data set, I can see I have college scores, but not college experience. So that is probably in the 4th edition. So I'm going to go back to useful websites and textbook data sets. And then I'm going to switch from the 3rd edition here to the 4th edition. And then scroll down to the bottom where I can get the data set description. And here I can see that there is a college experience data set on page 21. And here we have 79 observations, so 79 rows, and each row appears to be a student. And I can get more details about those students by reading the detailed paragraph down here or looking up the article related to it. And the 2 variables I'm interested in based on this scatter plot here are phone unlocked and feel good. And so phone unlocked here is the amount of time that a student uses their phone in unlocked state, i.e. total phone usage duration. Over how long? Okay, so for a duration of their time at the college. So extended amount of time, I'm assuming it's the same duration, amount of days, weeks, months for each student. And then we have feel good. Right now, overall, I feel good about myself. Not at all, a little, somewhat, very much, extremely. So a low score on that means they don't feel good about themselves right now, and a high score means they do feel good about themselves right now. And if we look at this data set here, it's pretty scattered. It's hard to see a trend. I kind of sort of see a downhill trend here. The negative correlation and negative slope indicate a downward trend to the data, but again, that's closer to 0 than 1 or -1. -1, I guess, on the negative side. If we throw the line in there, we can see that negative slope in there, indicating that the more one uses their phone, the less they feel good about themselves, perhaps. But again, this is a weak correlation. Now, again, if you take a later stats course, you look at a hypothesis test for correlation. We're not going to get to that here, so that might have some interesting results. But as far as we're concerned here, if this is not worth investigating, we want something with a higher correlation. The calculation of correlation, slope, and intercept are complicated. There are formulas for it. The book states the formula for the correlation coefficient in 2.5. We're never going to use that by hand. We're going to have an app like StatKey or a Spreadsheet do that for us. So let's take a look at a spreadsheet. So here I copied the data from StatKey into my spreadsheet, and I asked the spreadsheet to calculate the correlation. It uses the correl command, and when you bring up that command, so again, using a spreadsheet, you start by typing equals, then start by typing what you're looking for. I can see there's one thing close to CORR, that's correl, the Pearson product moment correlation coefficient. It wants the Y data first, the X data second. If I do something like highlight the whole column for the Y data, comma, whole column for the X data, then this is reusable. I can plug other data sets in here. The correlation coefficient is symmetric for X and Y, so it actually doesn't matter the order you put the data in, but the slope is not symmetric, and the slope has got to be Y data first, X data second, otherwise you'll get the wrong slope. Again, if we look at StatKey, we can see with the, let's go back to crickets. With the way the data is originally, with chirps as the explanatory and temperature as the response, we get a slope of 0.231. Now, the explanatory and response here are switched, so again, I should fix that. The slope really should be 4.254. So notice if you get the variables backwards, you get a different slope, which may not be the one you need. And given that temperature is likely the explanation why the chirps increased, could be other variables involved we don't know about, this relationship seems better than the other. So the slope here should be 4.254. I can plug any data I want in here now. So if in the homework assignment, I give you a column for explanatory and response, you could just highlight columns A and B here, delete, and then paste whatever data you want in. So perhaps it was this data over here you got from the homework. I'll come back to this example in a moment. You would just paste it in, and it will automatically calculate correlation value, slope value, intercept value. Charts are different because they involve typing in titles and choosing axes appropriately so that the chart might not be relevant, depending on how it was set up. And let me just reverse this to where it was. All right, let's check out another one. Again, I set up a similar spreadsheet and just a little bit more work on this. Same formulas as before, correlation, slope. Intercept is just intercept, pretty straightforward. Again, Y data first, X data second. Before you bother calculating these, you should check the graph to see if it's worth it. So my first step, given something like this, is grab the data and insert a chart. And sometimes Google and Excel will make the wrong guess as the kind of chart. So I'm going to say, no, I'd like a scatter plot, please. it's better. And if it looks like, yeah, I see a linear trend there, then after that, I would bother making these calculations. If you have a spreadsheet that's already set up to make those based on columns A and B, then no big whoop. You can then, once given the chart, ask for more information. So when you're in the edit menu, you can customize. In this case, in Google, it would be the series. And I would want to add a trend line to it. And I would also want to label it with the equation. So that's a quick way to get the slope and the y-intercept. R squared is not the correlation coefficient. It's the square of the correlation coefficient, which is a different number that has a different meaning. We're not going to use that in this class, so you can ignore that. Alternatively, if you have data, you can copy and paste it into STAT243. So I could take data from a spreadsheet or data from a homework assignment, copy it, and in STAT243, descriptive statistics for two quantitative variables, I could edit, delete whatever data is there, and paste in whatever data I want. And my data does have a hetero, so I'll keep that checked. And STAT243 will quickly calculate the correlation coefficient, slope to a few decimal places, and the y-intercept to a few decimal places, giving you a linear model, y equals mx plus b, that you can then use to make predictions. Predictions are when we take a value of the independent or dependent variable, the explanatory or response variable, and we use the equation to make a calculation. So for example, here, I'm going to make a prediction where the x value is 100. So if I bike for 100 minutes, about what will my distance be in kilometers? And I can see it's 20 something. And when I make the calculation, I'm going to use the slope and the y-intercept. So let's just redo that. So equals, to make a calculation, I want to take the slope. So I could use this value here or the one down there. Doesn't really matter. I don't need to have so many decimal places, right? Is it really necessary to have that many decimal places? Sometimes, not today. So I'm going to say my slope is about 248 thousandths. And if I multiply that by the 100, and then I want to subtract 2.03 roughly, I get 22.7. So if, according to, these are my recent mountain bike rides, according to my Strava app, if I were to bike for 100 minutes, then I would expect to cover almost 23 kilometers on my mountain bike. When you make a prediction for values that are within the data range, so 100 is within the range of x values here, that's called an interpolation based on the model. The model would be the equation based on the slope and the y-intercept. So the predictions I'm making are here based on y. We usually call the equation y hat, or we put a little cap on top of the y if that's easily done. Sometimes it is, sometimes it's not. And so here my equation would be 0.248 times x minus 2.03. So that's what I'm using to make my predictions. Now, what if I expected to bike for 200 minutes? How far would I expect to go? And according to that same equation, 2.48 times my time minus 2.03, I'm getting a distance of about 47.57. However, 200 minutes is way outside the range of the data. That is called an extrapolation, when you make a prediction based on your model with values that are outside the given range of data. So guessing at a distance over 40 kilometers is outside the range. Over 130-ish minutes is outside the range of this data. Anytime I make a prediction like that, it's extrapolation. And even with a high p-value, if you try to extrapolate too far from the data set, then it may be very unreliable, and it's hard to know. But it is something we strive to do, to find a good model to make predictions, and sometimes those predictions could be extrapolations. That is mostly what we're going to do this week, playing around with two quantitative variables and looking to see if there is some visual association that might be linear. If so, we calculate correlation, slope, and y-intercept, and then we use the given equation from the calculations to make predictions. Other thing you look at this term is how to interpret what the slope means, how to interpret what the y-intercept means, and then in the next section, we'll look at adding a third and fourth variable to make some graphs called bubble charts, in addition to some other cute graphical displays of data. All right, do good math this week. Most of the assignments are posted except the application. That will be up very soon. Take care. Do good math.